Hi, good evening all. Welcome back to our channel. Today we are going to discuss about the problems on jet parameter. Let's try to solve this problem. This is very important. A small signal equivalent circuit of a common base mode, common base mode of a BJT is shown below. Find the jet parameters for this. So he has given some emitter to base voltage, collector to base voltage. Let's try to relabel them to write down in our required format. Okay. So we know the equations of V1 as well as V2 as input voltages, and we are writing the jet parameters as Z11, Z12, Z21 as well as Z22 multiplied with I1 as well as I2. Therefore, the equation of V1 is equal to Z11 I1 plus Z12 I2 is one equation. Second equation is V2 is equal to Z21 I1 plus Z22 I2. So here the first step what we are going to perform is, let us make the output port as open circuit, that is I2 equal to 0. Substitute I2 equal to 0 here, I2 equal to 0 here. Therefore what we need to find out is Z11 is equal to V1 by I1. Let's try to find out first parameter, and Z21 is equal to V2 by I1. So let us try to find out these two. Okay. So now I am going to redraw the network in a simplified fashion, such a way that you can understand better. Okay. So here I am going to change the voltage, the input voltage as V1, and this has some RE, and this has some R base. So here you can see here, this is like an a current source in parallel to an resistor. I'm applying source transformation and converting into an voltage source. So therefore I'm going to get a resistor in series, and this is a current source multiplied with the resistor will be converted into voltage. Voltage source polarities are positive as well as the negative. So the voltage V I am going to write down it as product of current. The current is alpha I1 multiplied with RC. Therefore, this is an voltage source, current dependent voltage source, and this voltage I'm going to write down as V2, and this current as like this I2, and this current as I1. So this is how I'm writing, and I already told that we're going to make output port as open circuited. So this current will become 0. So whenever I2 becomes 0, what will happen? Let's try to draw the diagram. Okay. So whenever I2 becomes 0, so this voltage is available here, and this is the voltage at this point is V1. The voltage this I'm going to mark as some Vx, and these are the three voltage sources. So V1 by I1 I'm going to get. Okay. So I'm going to find out I1 now. So what is the current I1? So the current, so this is one voltage source, this is one voltage source, and this is one voltage source. Or the current I1 will not flow in this branch. Why? Because current has become 0. So these are open circuited. Therefore, current will flow only in this branch. Okay. So how to write down the current? I1 is the voltage at this point is plus V1. So that is equal to plus V1 minus 0 divided by R E plus RB. So from here we require the ratio of V1 by I1. So therefore when we bring this I1 to the denominator, V1 divided by I1 is equal to RE plus RB. So we have been got one parameter which is nothing but Z11 is nothing but the Z11. The ultimate units of this impedance is volts. Now we require the relationship between V2 and I1. So here we have V2. So this is nothing but V2, and this is nothing but the current I1. So I want to link all this parameter. So uh, I'm going to consider this branch. Okay, or let's try to apply the KVL. So here the current is leaving. So moreover current is zero. Therefore this is like open circuit. Just whenever current is flowing, the voltage, the outer mean I'm applying Kirchhoff's voltage law to link all the parameter at output port side. So whenever current is leaving, what is the leaving polarity? Plus V2. What is the voltage source we are having is minus alpha I1 into RC, and here it is some positive and negative. Whenever it is leaving, it's nothing but minus Vx is equal to 0. So I'm going to find out this V2 minus alpha I1 RC is equal to Vx. This is the unknown voltage at node X. But I want the relation between I1, relationship between I1 as well as V2. But unknown is Vx. So there is we have to solve Vx. So now how to write down Vx? Okay, I can link Vx as the current flowing in this branch is I1. So I1 with respect to Vx I'm writing. So I1 is equal to Vx minus 0 divided by RB. So therefore Vx is equal to, okay, so we can write down Vx is equal to I1 RB. So substitute this in this equation, V2 minus alpha I1 RC. So Vx I can write down it as I1 RB. So in this I'm going to take I1 as common. So V2 is equal to, when you take I1 as common, is nothing but RB plus alpha RC, but I require the ratio of V2 by I1. So V2 by I1 is equal to RB plus alpha RC. So this is the next parameter Z21. Okay. So again for the same network we are going to perform in reverse. So again what we have required is these two equations. Okay. So we have performed it output side. So now we have V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Previously we had made I2 as 0, now we will make I1 as 0. Therefore V1 by I2 is equal to Z12. Okay. And next one, what we are going to find out is Z22 is equal to V2 by I2. We are making I1 as 0. Okay. So the value of this is alpha I1 RC. So alpha I1 RC. Okay. So this is nothing but RC value. So now we are making I1 as 0. So when you make I1 as 0, the network is redrawn as like this. So here I1 is 0. This is an voltage source. So when I1 is 0, 0 into resistor also is 0 volts. Therefore, this acts like a short circuit with voltage V equal to 0, and we're going to have an V2 and the current is I2, and this resistor is RC, and this is RB. Now when I1 becomes 0, okay, so I1 is 0, 0 into resistor, automatically this is 0 volts, and this is also short circuited. Whenever this is short circuited, the voltage will be, whenever there is no resistor, this is V1, this is 0, automatically this voltage will be shifted to this point, and this point is nothing but V1, and this point is 0 volts. Now we require relation of V2 by I2. So how to write down I2 now? I2 is equal to V2 minus 0 high potential minus low potential divided by the sum of resistors which are connected in series. Therefore, V2 by I2 is equal to RB plus RC. This is the value of Z22. Next, now we want a relationship between I2, we want a relationship between I2 and V1. So what is the current in this branch which is flowing is only I2. So how I can write down is current I2, the branch which is flowing only this branch. So the voltage at this point is V1 minus 0 divided by RB. We require V1 by I2 is equal to RB in terms of ohms. Okay. So this is the value of Z, and now let's try to write down all the parameters in a systematic form: Z11, Z12, Z21 as well as Z22. Z22 is equal to RB plus RC. Z12 is equal to RB. So what is the value of Z11? The value of Z11 is RE plus RB. RE plus what is Z21 RB plus alpha RC. Alpha RC. So this is very important when you solve some multiple problems. So this is the ultimate Z equations. So if you practice only, the things will be very simple. Actually, what is given, what is needed. Okay. So first you have to see that the given network is this, and this is an practical current source. I converted this practical current source into an voltage source for simplification. So I got here. I applied the basic rules. I expressed this in terms of these two parameters. And this is one voltage, this is one voltage, this is another voltage. So directly I got V1 by I1. And here similarly I applied one KVL, and I seen that no equation will consist of Vx. So I transformed that Vx in the required format. So I got the resultant answer like this. Okay. And next, what we are going to do here is we are finding the next parameter like this. We are going to find out Z22 as well as Z12, and this is the resultant Z matrix of the required equation. So successfully we transform our given equation in this format. So here we are performing the input current is 0, and we find out Z22, and so you have to practice this kind of problems which make you to understand more problems. Hope you are able to understand. If you feel the video is useful, please like and share with your friends, and if you have any doubts, let me know in comment section. uh, what are the answers you are getting in your comment section, you can give a comment. And if you're watching the channel for the first time, please subscribe the channel. So this is a free channel for the benefits of student, and the channel name is KV Tulasi. So yours obediently Ram. Will meet in the next class. Thank you for watching.